In this video, again I am going to draw a graph between the maximum kinetic energy of the photoelectrons and the frequency of incident light. Yesterday in the previous video, already I have discussed that the maximum kinetic energy of the photoelectrons increases linearly on increasing the frequency of light. जैसे जैसे लाइट की फ्रीक्वेंसी हम प्लेट P1 पे बढ़ाए थे, निकलने वाले इलेक्ट्रॉनों की काइनेटिक एनर्जी भी क्या होती थी, लीनियरली इंक्रीज करती थी. So when you will draw a graph between maximum kinetic energy of the photoelectrons, which is denoted by Ek, and the frequency of incident light, which is denoted by nu. And this graph is what here increases linearly. And when you will extend this straight line graph, then you will observe this straight line graph cut this frequency axis at the point nu 0. Nu 0, this one is called lowest frequency which is required for that metal for the emission of the electron, and that lowest frequency is called what here, threshold frequency for that metal. Remember this. So nu 0 is what here, with this graph we can find the threshold frequency, this nu naught, and actually nu naught is threshold frequency. How can you define? The lowest frequency of light required to emit the photoelectron from a metal surface is called the threshold frequency for that metal. And if the frequency of light less than nu naught, अगर frequency of light इस threshold frequency से कम होगी तो मेटल उस मेटल से कभी भी फोटो इलेक्ट्रॉन का इमिशन नहीं होगा. It's not matter what is the intensity of light. So when you will extend this straight line, this will cut the frequency axis at nu naught. Where it cut the frequency axis, this will give the threshold frequency, and it cut the kinetic energy axis at this point minus b, this one. And you know, equation of a straight line, as you know, y is equal to mx plus c. As you know, y is equal to mx plus c, where m is the slope of this straight line and c is the y-intercept. So when you will write the equation of a straight line for this one, suppose slope of this graph is given by a, then you can write along y-axis what you are taking here, ek. So what equation you will write for this one, this straight line for this graph, ek, because at place of y, what you have taken along y-axis, ek is equal to m, slope is how much here, a. On x-axis, what you have taken here, nu, and what is the y-intercept? This y-intercept is minus b. And actually this equation or equation for this straight line is experimentally observed when we have drawn the graph between maximum kinetic energy emitted from this metal with frequency of the incident light. So now we can define the first, what is here, threshold frequency, and this threshold frequency is also called cutoff frequency. So what is the threshold frequency? The lowest frequency of light which can emit the photoelectrons from a material is called threshold frequency of that material or cutoff frequency of that material. इसका मतलब किसी भी मेटल प्लेट से, किसी भी मटेरियल के मेटल प्लेट से minimum frequency of light which is required for emission of the photoelectrons, that frequency is called, it's what here, threshold frequency for that metal. And remember this, if the frequency of the light is less than threshold frequency, then it will never emit the photoelectrons. It's not matter what is the intensity of light. तो हर एक मेटल के लिए एक लोएस्ट फ्रीक्वेंसी की लाइट रिक्वायर्ड मतलब चाहिए उससे फोटो इलेक्ट्रॉन को निकालने के लिए. लेकिन हमेशा याद रखिएगा, अगर लाइट की फ्रीक्वेंसी थ्रेशोल्ड फ्रीक्वेंसी से कम रहेगी तो कभी भी फोटो इलेक्ट्रॉनों का इमिशन नहीं होगा. एंड दिस थ्रेशोल्ड फ्रीक्वेंसी इज आल्सो कॉल्ड व्हाट हियर, cutoff frequency. And same experiment is performed by taking the plate P1 which already studied, I have given in the diagram. If the same experiment is performed by taking the different material of plate P1, then and again when a graph between the maximum kinetic energy of the photoelectron and nu is drawn. So here for the different metal of the plate P1, it observed that the graph was coming for this one like this. Suppose this one for the frequency nu 1. Here nu 0, and this one is what here for first metal. So we can write here this one is nu 0 1 for this metal. Suppose for this one this energy called minus B1 from here to here. For the second plate, for plate of the second material, it observes like this. Here this one is nu 0 2, and this energy is what here, suppose here minus B2. And here it observed that experimentally, it observed that for the different material, these graph waves comes parallel. Parallel graph means their slopes are equal. And you know, already you have written this formula for this one. Ek is equal to A nu minus B. So here A is the slope of this graph. And what you are getting, आपको क्या मिल रहा है कि हर एक मटेरियल के लिए ये ग्राफ हमेशा पैरेलल आ रही थी. पैरेलल का मतलब इनका स्लोप क्या रहेगा, सेम रहेगा. इट मींस A इज ए यूनिवर्सल कांस्टेंट. बट न्यू मतलब थ्रेशोल्ड फ्रीक्वेंसी अलग अलग मटेरियल के लिए अलग अलग रहेगी. और दिस B मींस एनर्जी intercept will be also different for the different material. So actually this experiment or this result is observed experimentally. So again from this graph, which is between the maximum kinetic energy of the photoelectrons emitted from the metal plate and threshold frequency, same graph, its equation Ek is equal to A nu minus B. And from this graph you can see when nu is equal to nu naught, it means if the frequency of the light is equal to the threshold frequency, this one, and when nu is equal to nu naught, if applied frequency is equal to threshold frequency, then at that time Ek is equal to 0. Because kinetic energy of the photoelectrons you have taken along y-axis, so its value on the x-axis becomes 0. So when nu is equal to nu naught, then you can say Ek is equal to 0. And now you put this value in this equation. So 0 is equal to A nu naught minus B, or B is equal to A nu naught. Actually B is what? B is the energy. It means this energy B is equal to A nu naught. And already I have told you by the different experiment, A is the universal constant. So this B means A nu naught. This B will give what here? Minimum energy required for the emission of the photoelectrons from a metal surface. Nu naught था minimum frequency of light, and B मतलब A nu naught क्या देगा? Minimum energy required for the emission of the photoelectrons from a metal surface. और later I will tell you, मैं बाद में बताऊंगा यही energy जो minimum energy required for the emission of the photoelectron from a metal surface, that one is called the work function of that metal. So as you know, this B will give what here? Energy. And this A nu naught will give what here? This B means A nu naught means minimum energy, and that defines what here? Work function. So how can we define the work function? Work function means minimum energy required for the emission of photoelectrons from a metal surface is called the work function for that metal. तो इसका मतलब हर metal surface के लिए एक minimum frequency of light चाहिए या minimum energy of light चाहिए उससे photoelectrons को निकालने के लिए. लेकिन ये confusion दिमाग में नहीं होना चाहिए कि थ्रेशोल्ड फ्रीक्वेंसी या वर्क फंक्शन सभी मेटल के लिए सेम नहीं होता. सभी मेटलों के लिए अलग अलग होगा, लेकिन किसी एक मेटल के लिए वही रहेगा. तो इट विल वेरी फ्रॉम द मेटल टू मेटल. तो रिमेंबर दिस definition of the threshold frequency and the threshold and the work function. And here I want to tell you, एक चीज मैं यहाँ और क्लियर कर दूं. Generally, several time it asked in the board exam, we define the threshold wavelength. So threshold frequency is what here? Minimum frequency of light required for the emission of the photoelectron from a metal surface. And for threshold wavelength is what here? Maximum wavelength. Remember this, maximum wavelength of light required for the emission of the photoelectrons from a metal surface is called threshold wavelength. क्यों? क्योंकि frequency अगर minimum रहेगी तो wavelength को क्या होना पड़ेगा? Maximum होना पड़ेगा. तो be careful in these two terms. maximum wavelength required. So in this way you can define threshold frequency as well as the work function for any metal. Now the laws of the photoelectric emission. Leonard and Millikan were the two scientists who gave the following laws on the basis of experiment on the photoelectric emission. First one is what here? The rate of emission of photoelectrons from a surface of metal is directly proportional to the intensity of light falling on that surface. Second one, the maximum kinetic energy of the photoelectron is independent on the intensity of light. मैं बताया था कि लाइट की इंटेंसिटी बढ़ाने पे रेट ऑफ इमिशन बढ़ता है, लेकिन निकलने वाले इलेक्ट्रॉनों की काइनेटिक एनर्जी नहीं बढ़ती है. तो सेकेंड लॉ, द मैक्सिमम काइनेटिक एनर्जी ऑफ द फोटोइलेक्ट्रॉन्स is independent on the intensity of light. Third one, the maximum kinetic energy of the photoelectrons increases linearly with increase in frequency of incident light. इंसिडेंट लाइट की फ्रीक्वेंसी बढ़ाने पे maximum kinetic energy of the photoelectrons or the kinetic energy of the emitted photoelectron will also linearly increases. Next point is what here? For each metal, there is a certain lowest frequency which is required for the emission of the photoelectrons, and that lowest frequency is called what here? Threshold frequency. And last one is what here? One more, fifth one. कि as soon as, चूंकि एक्सपेरिमेंट में ये देखा गया कि जैसे ही लाइट फॉल कराई गई ऑन द मेटल प्लेट P1, इमीडिएटली गैल्वेनोमीटर में डिफ्लेक्शन आना शुरू हो गया. इट मींस कि as soon as the light is fall on the metal plate, immediately the photoelectrons emission takes place. इसका मतलब ये photoelectrons मैक्सिमम कहां से आ रहे थे? From the surface of the metal. So on the basis of experiment of the photoelectric effect, these following laws were made by the Leonard and Millikan. Here one thing again I would like to tell you कि थ्रेशोल्ड फ्रीक्वेंसी और वर्क फंक्शन. थ्रेशोल्ड फ्रीक्वेंसी का मतलब ये मेटल प्लेट है और इलेक्ट्रॉन्स होंगे जो भी. जब मिनिमम फ्रीक्वेंसी ऑफ लाइट फॉल ऑन दिस मेटल प्लेट टू रिमूव द इलेक्ट्रॉन्स, केवल इलेक्ट्रॉनों को क्या करेगा? वो फ्रीक्वेंसी रिमूव करेगा, उनको काइनेटिक एनर्जी नहीं दे पाएगा. मैंने बताया था न्यू इज इक्वल टू न्यू नॉट, देन EK इज इक्वल टू 0. इट मींस दैट थ्रेशोल्ड फ्रीक्वेंसी इज ओनली द इजेक्ट द इलेक्ट्रॉन बट कैन नॉट गिव एनी काइनेटिक एनर्जी, केवल उनको डीअटैच कर देगा. या वर्क फंक्शन क्या होगा कि मिनिमम एनर्जी ऑफ दैट लाइट विच कैन रिमूव द ओनली इलेक्ट्रॉन फ्रॉम द मेटल प्लेट. ओनली केवल उस मेटल प्लेट से उस इलेक्ट्रॉन को डीअटैच कराने के लिए जो कम से कम एनर्जी चाहिए वही होती है उसकी वर्क फंक्शन. तो याद रखिएगा, इलेक्ट्रॉन को डीअटैच कराने के लिए केवल मेटल प्लेट से कम जो एनर्जी चाहिए वो किसके बराबर चाहिए? उसके वर्क फंक्शन के बराबर. और उनको डीअटैच कराने के लिए जो मिनिमम फ्रीक्वेंसी लाइट की चाहिए वो क्या कहलाएगी? थ्रेशोल्ड फ्रीक्वेंसी. सो नाउ नेक्स्ट वन इज व्हाट हियर? Planck's photon hypothesis, and this one is what here? Quantization of radiation. Several times this question we asked to define what is the quantization of radiation. I hope maybe many of them is known here. Planck's photon hypothesis up into Planck's quantum theory. Actually, the Planck's was given according to the Planck's, the light comes or the radiation comes in the form of the energy packet or energy bundle, and each packet or bundle is earlier called what here? Quanta, and which is later it's named as a photon. And the energy of each photon, the energy of each photon is what here? H nu, where H is what here? Planck constant, and nu is what here? Frequency of light. So, according to the Planck's quantum theory or Planck's photon hypothesis, light or all these radiations comes, light comes in the form of the energy packet or energy bundles, and these energy packet or bundle earlier called quanta, and later it is known as what here? Photon, and the energy possessed by each photon is what here? H nu. So you can say the energy of photon may be H nu or integral multiple of H nu. तो एनर्जी ऑफ फोटॉन में बी आइदर h nu or 2h nu or 3h nu like this, but not in between. इनके बीच में नहीं हो सकता कि 2.5 h nu 3.5 h nu, ऐसे नहीं होगा. It means the energy of the photon may be integral multiple of h nu. So this one or this property of this radiation is called what here, the quantization of radiation. So please also you go through your book here for finding the more details about the quantization of the radiations. Einstein explanation of the photoelectric effect, or this one is a photoelectric equation. This one is very, very important. Several times also asked here to write down the photoelectric equation. Actually, Einstein explained this photoelectric effect on the basis of the Planck's quantum theory, or on the basis of the Planck's photon hypothesis. So in 1905, Einstein explained the photoelectric effect on the basis of the Planck's quantum theory. And according to this Einstein explanation here, suppose this one is a metal surface, and light means here photon, क्योंकि इन्होंने प्लैंक की क्वांटम थ्योरी यूज किया था, और प्लैंक की क्वांटम थ्योरी में लाइट रेडिएशन क्या है, फोटॉन के फॉर्म में आती है. तो व्हेन लाइट falls on a metal surface, then the energy of this photon, means energy of this light, h nu, which is what here actually photon, is collide with any electron. Suppose, तो ये लाइट जो फॉल कर रही है इस मेटल प्लेट पे, जिस फोटॉन की एनर्जी कितनी थी, h nu थी, तो ये फोटॉन जिस इलेक्ट्रॉन से टकराएगा मेटल प्लेट के सरफेस से, जिस भी इलेक्ट्रॉन से टकराएगा, ये पूरी की पूरी एनर्जी इस इलेक्ट्रॉन को दे देगा और खुद का इसका अस्तित्व खत्म हो जाएगा. इट मींस होल एनर्जी h nu of this photon is transferred to that electron. And after getting this energy h nu, ये इलेक्ट्रॉन क्या करेगा, फर्स्ट अपने आप को डी अटैच कराएगा इस मेटल सरफेस से. और मैंने बताया था कि किसी भी मेटल सरफेस से डी अटैच होने के लिए इलेक्ट्रॉन को जो मिनिमम एनर्जी चाहिए वो किसके बराबर चाहिए, वर्क फंक्शन के. तो मान लेते हैं इस मेटल प्लेट का वर्क फंक्शन कितना है, W, और h nu पूरा इसको मिल गया, और h nu में से W तो खर्च हो गया किसके लिए, केवल इसको इस मेटल से अलग करने के लिए. एंड व्हाट अमाउंट ऑफ द रेस्ट, बचा कितना, h nu माइनस W. ये एनर्जी बच गई, h nu दिया गया, W खर्च हो गया इसको केवल यहां से अलग कराने के लिए, एंड रेस्ट अमाउंट ऑफ द एनर्जी व्हाट इज लेफ्ट, h nu minus W. And this energy h nu minus W is given to this electron जो यहां से निकला है in the form of kinetic energy. It means this will given to that ejected electron in the form of the kinetic energy. So what equation you will get here, Ek is equal to h nu minus W. So according to Einstein explanation here, according to the Einstein hypothesis, the photon when fall on this metal surface, then whole energy of the photon is transferred to that electron by which it collide. And after getting this energy, ये क्या करेगा, इलेक्ट्रॉन अपने आप को डी अटैच करेगा और बची हुई एनर्जी को काइनेटिक एनर्जी के फॉर्म में लेकर के निकल जाएगा. तो दिस इक्वेशन यू विल गेट हियर, Ek is equal to h nu minus W. And when you will compare this one with this formula which experimentally observe what here, Ek is equal to a nu minus b. याद करिए हमने बताया था experimentally this formula were observed, or this relation or this straight line formula comes here, Ek is equal to a nu minus b. So when you will compare this one, then here a is slope of this one, means which was constant, और ये a actually है क्या, ये है Planck constant. And this Planck constant is what here, universal constant. And what is B? B is the minimum energy required for the emission of the photoelectrons. और इसी B को मैंने किसके बराबर निकाला था, a nu naught. इसका मतलब B का काम कौन कर रहा है, ये वर्क फंक्शन कर रहा है, ये W. And if B is equal to A nu naught, then you can write here this work function W is equal to how much? At place of A you can write H. So this will come here, W is equal to H nu naught. It means by using this formula, W is equal to H nu naught, you can find the work function for any metal. And remember this, I hope maybe all of you know, nu is equal to C by lambda. Where nu is what? Frequency of light. C is speed of light. And lambda is what here? Wavelength of this light. So I hope maybe all of you know this formula, nu is equal to C by lambda. So according to Einstein explanation, what formula you are getting? Ek is equal to h nu minus w. और w किसके बराबर होगा? When you will compare from this equation, Ek is equal to a nu minus b. So a is actually Planck constant and b is what here? That work function. And already you know B is equal to A nu naught. So work function W is equal to H nu naught. When you will put this value here, then Ek is equal to, you can write H nu minus H nu. And what is Ek? Ek is the kinetic energy of, or maximum kinetic energy of that photoelectrons. And simply you can say from here, at place of nu, you can write C by lambda. And nu naught, you can write C upon lambda naught. So simply you can write here, Ek is equal to H, and here you can write nu minus nu naught. So this formula can also be written, since Ek is the maximum kinetic energy of the emitted photoelectron. So at place of Ek also we can write half mv max square is equal to H. At place of nu you can write C by lambda. Also you can write here H nu minus nu naught. Or you can write H C 1 upon lambda minus 1 upon lambda naught. Be careful about this one. हमने nu की जगह पे लिखा है C by lambda और nu naught की जगह पे लिखा है C by lambda naught. तो C को बाहर ले लिए कॉमन. So we can write here HC 1 upon lambda minus 1 upon lambda naught. Be careful. Here lambda is the wavelength of incident light. ये incident light की wavelength है और lambda naught क्या है उसकी? Threshold wavelength for that metal. So remember this. This equation is called Photoelectric Equation. So I hope maybe this topic is clear. Please, once all of you go through this topic here, what I have discussed today, and again I will give the last topic of this chapter. Thank you.